Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today's question comes from Chuck, KB3FKH. And he is asking about a variety of videos that I've done trying to put them together. Basically, there's some things going on with transmission lines. Transmission lines are an under-thought through piece of amateur radio. We tend to think of it as the black cable that connects the radio to the antenna, and that the magic is in the radio and in the antenna. And to a large degree, that's true, it is. But that piece of transmission line is hardly sitting there inert. Let's look at some special cases, okay, that you can use transmission lines for. First of all, the best case. If we look here, we see that we have a radio that is 50 ohms. We have a transmission line that is 50 ohms. And we have an antenna that is 50 ohms. And by 50 ohms, I mean 50 ohms resistive. The reactive part, the X part, is 0. By the way, you cannot build a real antenna that works that way unless you tune it specifically for one frequency. So there's going to be a reactive part. But ignoring that, 50, 50, 50. In this case, the transmission line here is truly like an inert piece of black something that we paid $1 a foot for to get out to our antenna. You're fine. You're copacetic. You don't need a tuner. You can go everywhere that the band is right. If you've got this set up, say, for 40 meters, if you have a multi-band antenna where this is true, you're going to be in good shape. Now let's talk about reality, okay? Let's talk about some things about transmission lines. First of all, let's take a sine wave. Okay. Now, let's take, we'll put a middle down here, right here. Now, let us suppose that the sine wave is a half wavelength, one wavelength, 3/4 wavelengths. Oh, say half, one, 1.5. Okay, the voltage here and the voltage here are going to be the same for that frequency. If you got a different frequency, then the wavelength is different. Let's draw a green frequency in here. I know some people have trouble with color blindness with green, so I won't try and use this too much. It's more blue-green. Okay, you see that the half wavelength points are entirely different at the different frequency. So what I'm going to talk about here, the fact that this voltage matches this voltage at the half wavelength point, means if you have a transmitter here and an antenna here, the voltage and current are going to be the same at each end of the half wavelength. That is a special case, okay, because it occurs at one frequency where that's the case. If you change the frequency, it's no longer the case. In the case where you have a half wavelength or an integer multiple of a half wavelength, then the impedance of the antenna will be reflected here. So if this impedance is, let's say, 75 ohms at 40 degrees, it'll be 75 ohms at 40 degrees over here. So what your tuner, when you tune the tuner to get this to 50 ohms at 0 degrees, okay, the coax, and by the way, this is regardless of the type of coax. It doesn't even need to be 50 ohm coax. It can be 75 ohm coax. The tuner sees the antenna. It's sort of like a special binocular method where the tuner sees the antenna. Now let's talk, okay, that was a step closer to reality. Now let's talk reality. You've got a sine wave. And we'll just take one wavelength. And let us suppose that you're doing something on 40 meters. So this is a 35 meter long piece of coax, electrically. Let's not worry about velocity factors and stuff like that. Note what's happening right here. Okay, when this is 0 volts, this is not. And when this is 0 volts, this is not. There's a difference. The impedance that you see here, I'll just put R plus JX. Okay, this is the real part, which we would love to be 50 ohms. This is the imaginary part, which we would love to be 0, because we don't like our antennas imagining things. Okay, but because it's not, notice here there's a positive or a negative voltage here when it's 0 over here. Remember that the impedance is the voltage over the current, okay? And here we have an impedance of a negative voltage. Here it's 0 volts. This acts, the coax acts as an impedance transformer. Okay? This is your normal case. This is the case that most people see. Sorry if I had that a little out of the viewfinder. There we go. Okay. Got to look up to that. So, when you tune this, put a tuner here. Remember that a tuner would normally tune, if the transmission line didn't do this, you'd have, looking this way, R minus JX, the complex conjugate, so that the power that hits here, the reactive power that hits here, will come back and be bounced right back. But it's actually R prime minus JX prime. Might even be plus, depending on the length of the feed line. Okay, the length matters, but it doesn't matter, because the tuner is not tuning the antenna. This is the important thing. The tuner tunes the combination of the transmission line and the antenna, and the antenna is affected by its environment, so you're tuning that part too, so that what is presented to the radio is nice 50 ohm resistive, if you can get it down that far. A lot of antenna tuners, the less expensive kinds, will never get down quite to 1-to-1 SWR, because the coil in there, you're only sampling spots on the coil. If you really want to get down to truly 1-to-1, you need one of those bigger units that has a knob. It's got, you're turning the coil and there's a little slider on it that picks just exactly the right part. With that, you can do that. But with the less expensive tuners, you can get close enough. Either use the internal tuner or use the external tuner. And if you're down to like 1.6 to 1, and that's the best you can get, that's good enough. Okay? Don't try to use the internal tuner to tune away what the external can't. You know, they fight each other. Get some wild circulating currents in there. Okay, let's see if we've come up with answering his question. I am confused by your discussion of what happens when the feed line length is not n over the wavelength. That's what I've got here. It's n times a half wavelength, but are you saying that without the tuner, I would have to find the fractional wavelength of feed line to feed the antenna? No, no, that's not what we do. You can make tunable antennas, like the mobile screwdriver or something like that. But generally we don't do that. We try to get our antennas close enough to 50 ohms that if you don't have a tuner or you just use the tuner in the radio, you can tune it out just fine. I would have to find the fractional wavelength. You can, using a Smith chart or something like that, or using some formulas, find out how long a piece of wavelength you need to match a given impedance here with a given impedance here. You can do that. However, that only works at one frequency. If you change frequency, the length, the electrical length of the line changes. So it is not a practical solution unless you only ever transmit on one frequency. Of course, hams are all over the place. Suppose I construct a loop antenna which has a characteristic impedance of 100 ohms. Well, it's going to have a reactive component to it. It's impossible to avoid. Do I need to be concerned about the length of the coax or ladder line I use to feed it? No. Ideally, you'd put the tuner right at the antenna. That's not practical for loops. It is practical for ground-mounted verticals, but it's not practical for loops. So you put ladder line on it, which can handle very high SWR without lots of losses, because again, impedance, voltage over current. If the impedance is high, you have high voltage, low current. Low current means low ohmic heat losses. 50 ohm coax, you can lose a fair amount if it's badly off, like a 10 to 1 SWR through coax. You're going to lose a lot as heat. By the way, if you've got a 10 to 1 at the antenna and coax back here and it looks like 8 to 1, the heat loss makes the SWR look better. That is a false sense of security because you're losing the rest as heat. Okay, I hope this answers the question of what happens. Now, can you use this? Yes, you can use this. If you need a phase shift of a certain amount, like you're going to phase 3 antennas, you've got 3 verticals, and you're going to phase them. And if you put in the coax here, you can calculate the lengths of the coax that you want to put to these 3 here, so you get a particular phasing so that you can get an antenna directional in that direction. Okay, now usually we switch phasing lengths or quarter waves or half waves. By the way, I mentioned the half wave length of an antenna. What you put in here, you see out here. If you do a quarter wavelength, you do an inversion. Okay, because here the impedance is 0. I'm sorry, the voltage is 0, the voltage is 0 here. Here the voltage is 0 here. Here the voltage is max. Okay, so you've got a very different impedance, and I forget the exact thing, but it's quite interesting what happens. Now, if you take a quarter wavelength stub and you short it on the end, short the inner and outer or the 2 pieces of ladder line, this impedance here will be, in theory, efficiency, because your voltage here has to be 0 because it's shorted. And you go a quarter wavelength and your voltage is at its max, meaning your current is at its min. Voltage max, current min equals high Z. Now you can use this if you feed this to an end-fed antenna, and so the impedance is 0. Here it's very high, usually be about 2K, something like that. You find the point here where it's 50, and you feed it here, and this is how J-poles work. You got a half wave dipole. Okay, it's 0 ohms here, very high impedance here, so you're feeding on the end of the dipole's the high impedance end. You find the point where it's 50 feet at there, and that's a J-pole. So yeah, you can do things with these transmission lines. Whole books are written on transmission lines. And there's, I think, 2 chapters in the ARRL antenna book on transmission lines. Those who are into Smith charts, if you've heard of Smith charts, you've heard of it if you're an extra because it was on the test. Smith charts actually help you figure out things on transmission lines. It's a transmission line tool. So, hope that helps. A little fun with transmission lines there. So there you have it. And if you'd like to help support this channel financially, you certainly may through dcasler.com/support. Lists a whole bunch of different ways. Also, please subscribe, please like, please share. And until we next meet, 73.